So today's session is Vision AI for logistics. We're going to be reviewing a report about how logistics organizations are using AI and taking a look at a few examples, success stories, best practices, things like that. My name is Patrick Descher. I'm from Roboflow, as you might guess. If you aren't familiar with us, we provide an end-to-end platform for developing and deploying computer vision solutions. And I'm very happy to be joined today by Donovan Crew, who is a senior software architect at Lumenalta. Donovan, would you like to say hi and introduce yourself to everybody?
Yeah, hey. Donovan, yeah, I've been a software architect for as long as I can remember, and I'm one of our leads at Lumenalta. And for those of you who don't know Lumenalta, we bring elite engineering teams to help companies move faster, whether building AI or modernizing data, launching new data platforms.
Nice. All right. So to get started, the first thing that we're going to look at today is a recent survey that was conducted by Lumenalta, and they were generous enough to invite RoboFlow and myself to participate in this project. We have a report that includes data from a survey of logistics professionals on the state of AI implementation at their organizations. There's a lot of information in this document, and we're going to review a couple of the points from the survey and then a couple other kinds of best practices type things. During the webinar, we aren't going to be able to review everything in there, but if you're interested to check out the whole thing, you can download it. Now I'm going to dive right in to the survey, and the first thing is just the basics. We had over 900 people from the logistics industry submit answers to this survey, and as you can see, the vast majority of them are located in North America. Now, the first thing to take a look at here, at a really high level, we asked the survey respondents about what stage is your organization in regarding AI adoption. And we saw that 32% of them said that they had pilot implementations going on. Another almost third said that they have full-scale production adoption. And then the remainder said that they are in that initial research exploration phase. So we can see that, over 60%, almost kind of 2/3 are at least in having some pilot program going on or they're in production. And from there, we wanted to go, one level deeper and share this response about the top applications that we see in logistics. We asked these survey takers a question: in which logistics functions are you currently using or planning to use AI? And this is a multiple choice question where people could choose different items that were relevant to them. So here we just see the top three most common applications that were reported by these logistics professionals. The first, number one, being real-time tracking and visibility. Number two is inventory management, and number three is customer service. Now, personally, as somebody working on a lot of computer vision projects, and I think about how computers can look at things in the physical world, I'm really not surprised to see real-time tracking, visibility, and inventory management at the top of this list. That totally aligns with my own experience. Donovan, I was curious, you also have a lot of experience working out in the field with logistics organizations. How does this kind of top three list kind of jive with your experience?
Look, I mean, it's perfectly in line with what is happening right now and what logistics companies are asking for. But we do also see like lots of requests for load optimization, making sure trucks are carrying pallets correctly, where they can optimize space, in safety monitoring, making sure that workers are wearing the correct PPE and not like behaving badly while doing the job, preventing injury and accidents, etc. And then warehouses, autonomous mobile robots, right? Making sure that they're not crashing into things and that they're navigating warehouses correctly. So it's quite a broad field, but these top three definitely align with what's going on right now.
Nice. All right, cool. All right, so moving on, there's one more point that I wanted to take a look at in the survey before we started reviewing a few other items, and that is we asked people a question around operational efficiency gains. We asked them a question that was kind of like, have you observed efficiency gains at your organization recently? And when we look at all of the respondents, we had this baseline number of about 51% of people said, yeah, we've seen some operational gains, efficiency gains recently. Now, kind of self-servingly, as somebody from RoboFlow, I was very interested in this next stat where when we carved out that Vision AI users, so we just looked at the people who said they are using Vision AI at their organization, we saw that they reported having these efficiency gains at a slightly higher rate than the baseline. And that's kind of leads to my, I guess I should say, motivation for wanting to have this session today, where we saw organizations, some of them are testing, some of them have AI in production, and then some of them are reporting that they see efficiency gains with computer vision. And I wanted to review a few of the use cases and some of our experiences around how organizations can be successful with Vision AI. I won't spend too long on this slide, but between our research in this survey and then just our experience across our two teams, we compiled a quick list of some of the top use cases that we've seen when it comes to deploying computer vision at logistics organizations, from tracking misplaced items in a warehouse to predictive maintenance for your fleet or specialized equipment. There's loads of things that you could be doing with computer vision. Now, today we were going to review a couple of these use cases a little bit more in depth. And the first one of those would be around automated inventory management. Earlier in when we're reviewing the survey, we saw this is one of the top things that people mentioned dealing with is visibility and automating certain operations. So on the screen right now, you see a looping video. This came from actually a webinar that we did a couple of months back where we were talking about in depth how to create a computer vision model or multiple models that are capable of recognizing containers in intermodal yards. And then also, more importantly, detecting the ID on those containers. You can see in this video, there's that red ID tag. And what a computer vision solution like this enables is you can, instead of having somebody spending hours every day driving around a yard, updating the inventory one by one, you can automate this process so that you spend way less time on updating inventory, but you can also improve accuracy because you're reducing human error, and then you're making it possible, say, for a team to locate a specific item, a specific container more quickly. And I've also seen a lot of organizations where, they take that visual data, say the container ID, and then they can connect it to GPS data. And then from there, I have an example here, but you can create a real-time map that would show the geolocation of all of your containers in a yard in real time so that you can understand the utilization of a yard. You could make some better decisions that way. And so this automated inventory idea is something I've seen at like a lot of different organizations, not just containers, warehouses, things like that. Donovan, I think you also have some experience working on projects. Would you be able to tell us a little bit about that?
Yeah, sure. Lumenalta recently worked with a large carrier company to craft an AI that monitors vehicles and trailers across around 150 terminals, enabling real-time visibility, better load balancing, similar to what I'd mentioned earlier, load optimization, etc. And purely just by automating truck entry and exit, we were able to eliminate manual logs, which reduced errors, right? And freed up humans to do higher value tasks. So they don't have to sit and monitor the correct trailers are coming in or going out, etc. That's all 100% automated. And with clearer visibility, there was like a drastic improvement, not only just on the trailer utilization, but reducing congestion during peak times. Like, I mean, at any form of terminal, peak times are an absolute nightmare. Simple automation, fully automated, reduced that drastically.
Nice. Yeah. Something, I guess, to have a quick aside, you just reminded me about. I was chatting with somebody else about something like this a long time ago where they said, well, why don't we just put like RFID on all of the containers and that way we could scan it? I think I was like, oh, actually for a second I was like, that's pretty good, but also there's two things that I'm thinking about, which is installing a million RFIDs on these containers is
Yeah.
going to take a lot of work and a lot of time. And the nice thing about Vision AI is that we don't need to install anything. It's like, would you rather install a million RFIDs or would you rather have one truck or one gate have a camera that can
Yeah.
then scan those IDs that are already painted there? So that's kind of like one sort of efficiency gain. And you also reminded me another thing. There's like a benefit I saw, which is instead of having somebody driving around a lot for 4 hours at a time, we kind of like don't need to do that anymore. And then that can reduce even just some simple things like, gasoline usage. Have you seen some other kind of like ancillary benefits when you were working on
Well,
projects like this?
but automating, you can do, and with vision, I mean, you can do a ton extra, right? So assess damage on the containers that are coming in, on the trucks that are coming
Mhm.
in. The very clever stuff, you can assess weight, based on the truck's height, full load, no load. So it does seem like quite, Terminator kind of, right? Like it's super advanced, but it's definitely doable. And to your point, an RFID can't do that. An RFID can't assess whether or not a trailer is being damaged, or a container is damaged before it hits the dock. So yeah, definitely a ton
Nice.
of ancillary benefits.
Cool. Nice. Well, and I like that you mentioned the damage because that was actually the next topic that we wanted to talk about. Let me kind of move things around a little bit. All right. So here, in a second, I'm going to pass it over to Donovan to talk a little bit more about this. Just first to quickly share, I've also seen a lot of situations where an organization wanted to assess the condition of an item that was, say, arriving at a warehouse or arriving in a parking lot, if it's like an automobile or passing through some kind of gate, because, I think a major issue that logistics organizations struggle with from time to time is damage claims and logging the condition of every item, understanding which item is which, and then later being able to go back and reference what the condition of that item was, just in case they get a damage claim. And so here I have a really quick, kind of fun video that I made yesterday. This is not production ready. This is just a quick little thing I did in like 5 minutes yesterday. I couldn't find good public stock video of pallets coming into a warehouse, and one of them was damaged. But what I did do is I took this video, and I'm assuming these are some kind of ventilation hole in these boxes. And I just really quickly trained a model that would be able to recognize the holes in those boxes across the frames in this video. I think, spent some time labeling maybe two or three of the frames in this video, and then I tested it out on the rest of them. So again, just a little quick fun thing I did, but I wanted this to serve as just like a visual idea of you can train a model to recognize corrosion, scratches, dents, different dings, things like that in items as they're being checked in. And Donovan, I think you had some cool ideas about how organizations could implement something like this. So I was going to pass it over to you again to talk about that.
Yeah. And I mean, Patrick, to your point, you said you spent a little bit of time classifying holes. And to that point, like a lot of logistics leaders are eager to adopt generative AI. But where it often falls short, or where there are like foundational roadblocks, is you've got bad data or limited visibility, disconnected systems, tons of data coming in from multiple different sources, etc. So non-uniform data. And with Vision AI, you've done that in half an hour to an hour, right? So you're able to get something working up extremely, extremely quickly. But that's not to say that you can't leverage generative AI after you've identified stuff. I think the true power comes in is like thinking broader picture, right? So for instance, to Patrick's point, this is like a conceptual thing, but extremely doable. Using Vision AI to detect packages, or using an object detection model to identify packages on a container or a pallet or a conveyor belt, etc., through a distribution center, running a classification model to identify damage. And from there, you can trigger a whole bunch of things. But the nice thing is now we can start implementing generative AI with very little data, right? We can use an LLM, or we can use an LLM to identify or to further assess the level of damage that's on a specific identified piece of damage. And then from there, using agentic workflows or LLM delegation, you could move further down the line to fully automate something that happens, right? So if it's on a conveyor belt, for instance, depending on the level of damage, you can decide whether or not to ship it back to the sender, or pop it into a bay for inspection. Perhaps it was misclassified, or it's not such bad damage. So you could really move a lot further combining Vision AI with generative AI without needing that huge foundation of like, gosh, we need to get our data in order. We need to get everything 100% perfect before we can actually start integrating Vision AI and generative AI, or LLMs, etc. So I think there's a massive benefit or massive opportunity combining the two with very little data, specifically with the leveraging Vision AI as a primary data source.
Nice. Yeah, I love this idea of weaving together multiple AI models to complete more complex tasks. I think one thing that I was going to add to that is earlier I showed off this video of identifying containers in an intermodal yard and then scanning the ID. So that was also another example where, we have all these IDs, we have imagery and we see there's text on a container. And if we just straight ahead applied that, optical character recognition OCR model to the container, we would get all of the text that was written on the back of it. We would get the logo, we would get the name, and then, maybe that's not relevant to our database. We just want the ID. So in that example we saw earlier, it was like, first step is just find the ID and then crop that. So now we have a new image, and that image is only the ID. And then from there, we could pass it over to another model that is good at reading text. And then that way we get a more accurate, I would say we get a more accurate solution by weaving together multiple models. And I like what you're talking about here, because it's like the same idea of, I can teach a model to recognize the holes. If I want a little bit more information about the hole, or if I want a little bit more information about the damage, it might be good to pass that to another LLM to help describe, or another VLM maybe. We took a look at a couple success stories and a couple of our data points from the survey. I wanted to get back to a couple points of the survey and then share some other things about, well, we looked at some success, we looked at some stories. If you're just getting started with computer vision, AI, or maybe you're looking to expand, you might be thinking about, how do you make these projects more successful? And I wanted to review this part in the survey, where we asked people what key factors contributed to successful AI adoption at your organization. And again, this is something that people could select multiple answers. So here we have a list of the 3 top answers that they provided when we asked them this question about how to be successful with AI. And the first one is about having access to high quality, well-structured data. And the second one is about successful change management and team training. And third is about integration with existing systems. I wanted to take a little bit of time to talk about the first one here and some of my own kind of personal take here. As somebody who has spent a lot of time thinking about and answering questions related to computer vision, um, and also seeing a lot of organizations creating custom AI models to interpret visual data. For example, a little earlier, my video where I was showing off the detecting holes in a box, that was just a little custom model that I made myself. So I've seen a lot of organizations developing these to handle their needs, and it's based on data that they own. Yeah, I totally agree that this is a foundational requirement to creating your own AI model, is making sure that the data is high quality and it's representative of your production environment so that the AI model will be able to operate in that production environment. Now, what I did want to stop here though and say, yeah, I totally agree that this is one of the top questions you should be asking. But also at the same time, there are a lot of modern tools and technologies have been evolving. So, once upon a time, if you wanted to train these custom models, yeah, you would need to hire like all of the machine learning PhDs in your area and spend like 6 months collecting data, and then you might think, okay, I need to collect like all of the images from the beginning of time and have a really huge data set. But we don't really see, like, that's changed a lot. Things have gotten a lot easier in terms of having tools like RoboFlow to help you manage your data set and get it into that proper structure. Um, but I also wanted to take a look at this slide from research that I did a few months back. There's a lot of text and numbers on this slide. I apologize about that in advance, but I wanted to walk through this step by step because it's related to that point of having a data set. So a few months back, I had looked at a group of data sets and AI models from organizations that were using RoboFlow. I think, if I remember correctly, I had about 4,000 data sets in that pool that I was researching. And over here on the left, I have a column that says model use case. And in there, there's things like predictive maintenance, production cycle time. These are all data sets and models that I saw were managed and trained by different organizations using RoboFlow. And then next to that, there's a column of versions. Now, this refers to my data, it spanned a 6-month period. And during that 6-month period, I saw these organizations were retraining their vision model every now and then at regular intervals or from time to time. And this number is the amount of versions that they created during that time period. And so we see down at the bottom of that list, we have a quality control model that one organization was working on. And in that 6 months that I was examining, they retrained their model 60 times. Then the column next to this, images, it says, plus 995. These are the number of images that were added to that training data set during the time period. And then next to that, finally, we have this table that says the accuracy improvement. And so these organizations, they were adding more sample images to their training data set, and then they were retraining. And what this chart over on the right is showing us is the accuracy improvement that they got by expanding the data set and retraining. So we can see at the top, there's that predictive maintenance example. They had a score, like an accuracy score assigned to this model. It's like a standard accuracy score that's assigned to every model. At the beginning of 6 months, they started at, it looks like just shy of 60% accuracy. But after adding 900 images and retraining, it looks like they got close. It was probably like 97, 98, 99% accuracy. So I wanted to use this as an example of, yes, you need high quality data that's representative of your production environment, but I would caution against, like, you might not need a giant data set to get started. These days you can train an initial model and get that, with a smaller data set and get it into a testing environment, get it into production. And then from there, you can gather more images and you can have your AI model assist with labeling them. And that way, all you need to do is review those labels that were applied by the AI model, and you can expand your data set and improve accuracy really significantly without having to spend too much effort. There's this one example I see. There's this production cycle time data set here, and it looks like they added 15,000 images to their data set in that 6-month period. This was all anonymous data, so I don't know how they were doing this, but I really hope that they were not labeling everything by hand. I'm going to assume that they were using their model to help label and expand that data set. All right, that was a pretty long spiel by me. So when it comes to this success factors and what people reported, helping them be successful, there's a second one here about change management and training. And to be totally honest, I'm not an expert on this. So Donovan, I'm counting on you to tell me a little bit about, do you have any nuggets of wisdom that you've seen to talk about this?
Yeah, and this isn't change management as in like, hey, we're going to release something to production change management. This is corporate thinking, right? Or ethos in general, right? So introducing new technology is a challenge in itself, but training itself isn't always enough, especially when it comes to AI and the way to think about AI. AI shifts your workflows and shifts the way of understanding. So not just necessarily the tools. Thinking bigger, understanding problems deeper, or even taking a huge problem and splitting into really, really small problems to, eventually get one big problem solved, as opposed to trying to attack them as one massive thing. And success when it comes to change management and training, definitely depends on trust, clarity, and involving teams early on in the project, right? You can't be building something and then hand it off and, hey, this is how it works, good luck, to a specific company. And the reason I say that is obviously we insert elite teams into companies and we don't enjoy handing stuff off right at the end of a project. So software development, or a good software development, isn't just about building the tech, right? A good partner also helps you, like helps the people that need to maintain it, that are going to be growing it. It brings them along with them. So as the product progresses, as it's getting built, everybody understands exactly what's busy happening and how to maintain it in future. And funny enough, Lumenalta did another recent study, which I'm sure Julie can bring up and post in the channel as well, where only 20% of companies surveyed on this specific study conducted training monthly. So, I mean, that's quite a small amount, but 72% of them believed that upskilling was more cost effective than hiring externally, which is quite a huge difference in understanding, right? So upskilling takes time. It takes an extreme amount of time. Yet partnering with experts like Roboflow, Lumenalta, etc., delivers a fast, low risk ROI, right? So you can bring people in that are going to train the people that are going to be maintaining it, that'll teach people how to think about AI or vision AI or, agency, etc., as it moves on while being built. And then eventually you'll have playbooks that you can move on as a team throughout the future development. So I think that's the biggest thing to think about when it comes to, well, that's the biggest contributor to success is when it comes to like change management and training.
Nice, great. Thank you for sharing that. All right, let's move on. This is the final piece of the survey that I was wanted to review today. So, we asked people about what made things successful, and then there was also a part of the survey that got into some challenges and some things that they're changing. And this also kind of ties into what you were talking about of training, teaching people about new technologies. These survey participants about questions around the significance of the AI skills gap, and are you doing additional training? Are you hiring for new roles? Are you looking for partners to outsource? We had this result of just the vast majority of organizations are putting resources into skills training around AI implementation.
And partnering with somebody that knows what they're doing and moving along with changing models. I mean, GPT-5 is coming out in a few days, which is going to drastically change again. Moving along through your AI like journey with a good partner definitely helps. It keeps you on track. There's a quick story where I met somebody probably about 15 years ago, and he was studying PHP 5 in university, and I was like, "Well, guy, we're already like using Node.js now," and he's like, "What's Node.js?" And unfortunately, the same speed of technology is happening right now. Models are ridiculously quick to be released, and they're becoming so efficient that knowing what to look for and knowing how to develop those, having had 15 years experience in AI and machine learning, etc., definitely does help move a team, accelerate a team along whilst busy implementing either Vision AI or Vision AI and agentic approaches, etc.
Nice. Yeah, I wasn't going to linger here too long for myself personally because I sort of ended up talking about this a little bit earlier. I was thinking when I saw this about personally, my background was not in machine learning, it's not in computer science. I was actually doing like language education, things like that. Not computer language, just like human language education. Once upon a time to develop, custom AI solutions, like I said, you would have to have multiple PhDs or just people who have specialized expertise in machine learning working on these things. And now there's a lot of tools available if you want to create a solution where, I've seen a lot of people, I've talked to a lot of people where they're in software development and they don't have any background in machine learning, but just because of the tool sets that are available now, they were able to create a custom model in like a week or a couple of days and then get that into their application or get that into their environment. All right, so with that, I was going to wrap things up on the note of upskilling, and then training your team. If you do need help with, training and deploying a custom computer vision solution at your logistics organization or any organization, and then if you need some help, accelerating the integration, the strategic implementation, go ahead and schedule a call with, Roboflow and Lumenalta. Will be able to help figure out some of the questions and considerations that could go into developing that before we go into Q&A. Thanks for listening to this presentation. If you're watching a recording of this somewhere later on and you want to join a live session, you can go to roboflow.com/webinar. We have a session every Thursday that's like this, talking about some topic related to computer vision. And before we start talking about some other things, just a quick heads up that next week's topic is going to be a fun one. We're going to have a guest from another organization where they've been using computer vision to teach their robotic arms in manufacturing scenarios to handle more complex tasks. So that should be a fun one. I don't get to talk about robots every week on this webinar series, so I'm very happy to see robots coming up. And yeah, with that, Donovan, the way we usually do this, I think I gave you a heads up, but we have some questions in the chat that I saw come in. We have a few minutes to go through some of those, and I see there's actually a couple of them already. And actually, the first one, what's going on here? We have Lucas, and he was saying, Donovan from Crew, I'd like to know how to choose a bike or a motorbike when you know the trip before machine learning. Maybe I'll come back to that a little bit later.
Yeah, unfortunately, that's impossible,
Yeah.
man. I've got too many bikes and too many motorbikes. There's a nice one from Kevin that says if you've got niche down data and
Yeah.
can you use AI to generate synthetic data? So quick background, I'm a type 1 diabetic. I cycle for health, etc. And I recently wrote a machine learning model that could detect my blood sugar dropping during a long gravel race and tell me it'll find a restaurant in the area and order food for me with the right amount of carbs in it. And yes, definitely you can use AI to generate synthetic data, and it can be like the reason I gave you that story is I used quite a bit of synthetic data to fill in data where I had missing location data or missing blood sugar data, etc. And you can actually use AI to generate synthetic data that's wrong. which is a good thing, right? So you're testing against good data and negative data. So you reinforced learning over like a broader data set as opposed to just, hey, this is what good data looks like. Because often, especially in logistics, often the data that we expect is not the data that we get. So yeah, guaranteed.
Yeah, I like that. I've seen some experimentations when it comes to synthetic data also to expand a data set where um, perhaps you're trying to detect, for safety reasons, you're trying to detect a leak of liquid in a certain environment, and you don't have enough example images because thankfully you haven't had a lot of leaks happening previously. So you can use some synthetic data to enhance that data set and expand it. That stuff, there's actually some kind of cool research going on, but it's kind of early days and I'm not an expert on it. So maybe in the future we'll be doing a webinar about that topic as we have more. There's one here also. Early on, we got one from Lucas as well about it's actually more of a comment. You can use data augmentation to improve without the need of using generative data. I guess this is like a comment. But I did want to talk a little bit about the data augmentation because um, I think that fits into the story I told a little bit earlier about yeah, you need good quality representative data, but you might not need to have a giant data set. I saw one organization that they are a very large producer of minerals, metals, and they had a use case where they had these rocks, because they're processing minerals. They had rocks coming down a conveyor belt. They needed to monitor the size of the rocks as they came down the conveyor belt because the size was indicative of the rock crusher. There's like a equipment that crushes up the rocks, and if that equipment is not behaving normally, or maybe there's wear and tear over time, it will result in the rocks getting larger. And if the jaw crusher is not operating properly and the rocks get too large, then it can cause just like really horrible problems down the line when they're processing them. So they had this computer vision model to measure the size of the rocks on the conveyor belt. And they started with about 300 sample images, and they used this data augmentation technique to just do some basic augmentations, I think, just, flip them over, change the size, stuff like that. And they just doubled the size of the data set. So it was like 300, 600. And then that got them an accurate vision model. They had a question about what hardware requirements are recommended for implementation in logistics when aiming for cost efficiency. This is a really giant question, right? Because there's going to be all sorts of different use cases. And I was thinking I have a couple things that I could talk about here, which is when you're selecting hardware, I would say for logistics, in most cases that I've seen, we want to think about the camera. We want a camera that's kind of small enough to fit into the environment where you want to solve whatever challenge you're dealing with. We have like a really quick saying, which is just like, if you want to solve a problem with computer vision, you need to be able to see it. So first, you're going to want to think about camera placement and can you get a camera that can capture like footage and can it fit in that environment? Thankfully, cameras are getting like smaller and more powerful. And then I think the second thing is we want to think about latency needs. Like, am I going to be processing video? Am I going to be processing a single image? Is it going to need to happen real time? If it needs to happen real time, then you're going to want to think about compute and having something that is, on board. I've seen situations where we have the small kind of mini PC GPU that can actually live on a vehicle and it can handle the AI processing in real time. If latency in real time isn't really necessary, then you could think about, collecting your data and then processing it later, either in the cloud. But Donovan, just real quick, did you kind of have any thoughts about what are questions or what are considerations that you like to tell people to think
Yeah.
about when they ask about hardware in logistics?
Yeah, to your point, Patrick, it's broad, and cost efficiency is definitely plausible or possible when it comes to hardware, but depending on what you're doing. Biggest question that I always have, my favorite question to ask is, okay, should it work when the power's off? Should it work when the internet's broken? Those are kind of questions, especially like mission critical items that yes, you can run, smaller models locally, that don't necessarily depend on the internet, or local power grid. So definitely those types of questions. Unfortunately, though, the deeper down that rabbit hole you go, the cost increases, right? So if it is items, like I definitely recommend going for initially implementing something that is beneficial to the company that's not necessarily mission critical, that'll enhance your ability to do business and take it from there, right? If you see a huge ROI on that, you can slowly but surely start integrating more complex and more solutions, especially when it comes to mission critical stuff that doesn't rely necessarily on the internet or the local power grid. I think those are my predominant questions.
Beautiful, cool. All right, well, we went a little over time, and Donovan, I think it might be getting a little bit late in your part of the world, so I'm going to wrap things up here in a moment. I do see we have a couple other questions remaining. I'll do my best to answer anything. There will be a couple follow-up emails that we have to people who registered and joined today. Hopefully, we'll get the recording up sometime in the near future if you want to review any of this content. And like we also said earlier, there is this report available on Lumenalta's website. There's a link to that if you'd like to go check that out after you're finished watching this. Thank you very much to the audience for joining today. I really appreciate you. And Donovan, thank you for joining. Do you have any kind of final last things that you want to talk about, or
To your point, I think we're on time. I do want to say that the Vision AI and AI in general, it's an extremely exciting time to be alive. So definitely take advantage of it while you can.
Nice, cool. All right, well, thank you for that. And yeah, really good chatting with you today and for having everybody with us. Thank you, and please enjoy the rest of your Thursday, everybody.